I'll start with basic introduction of software. Let's see. Okay, type CAE, you'll see the option, application option, open it, command prompt will be open. Okay, so Abaqus basically includes standard explicit model, then CFD, and then electromagnetic. We are concerned with standard models and explicit models. So select with standard and explicit. Basic layout of software is this. This is model tree. Different modules are there. Total drop down part, property, assembly, step, interaction, then load, mesh, optimization, job, with result visualization. Okay, this is a option menu, file for saving, then importing parts, models, viewports, view, materials, section, profile. Okay, so always we start with part. All the options are available in tree also, so you can select it from tree or else you can select it from module. So let's see the problem. Okay, so problem is bar constant cross section area having length 1000 mm, one end fixed, one end loaded with 1000 Newton, single direction. Then Young's modulus, that is a property of material, mechanical property, specified 1.2.1, 10 raised to 5 Newton per mm square, or you can say megapascal. And the area is also given, that is 500 mm square. We have to find out nodal displacement, stresses in each element, and then reaction force. So in FEA, we basically break this actual problem or convert it into discrete model or elemental model. So if you see, we can break this model into, say, single element. Don't need to create multiple elements, so we can create a single element with two nodes. So this is 1D, one dimensional element. Let's see how to create it in Abaqus, then how to apply load, how to fix one end, and how to get the result, that is nodal displacement, stresses, and reaction forces. So displacement is specified by U, stresses and then forces. Clear? See. Okay, go to part, then create part. You can go from part manager also, create, or else you can double click on model tree, or else right click and then create. Multiple way you can approach the same key. Just go with short key, part, say single, or say bar element. Okay, so we need planar element, we need wire. We are creating a single element with two nodes. That's why I selected planar, plane, x and y only. Okay, and then wire element, line. Clear? So total length is, we are having 1000. That's why we are selecting approximate size, uh, a bit larger, 1100. Okay, so this is our viewport, x and y. Go to line. Okay, always start from origin. See, x and y 0 0 when we start from origin. Okay, just randomly click anywhere. You can specify x and y coordinate also. So I'm providing the length. Before that, just fix the, okay, so one end is fixed. Now I can provide a dimension without displacing it. So it's created, close it, done. So my element is created. Now just apply the properties, Go to create properties, say material 1, in problem elastic properties, that is Young's modulus is provided. See the value 2.1 into 10 raised to 5. Okay, so 2.1, so 10 raised to 5, e raised to 5. Okay, Poisson's ratio basically 0.33, 0.29 according to grade and everything. Let's see 0.33, no problem. Okay, so material is created. See, material 1 is created. We will create a section, assign the material, and then assign that section to our part. So let's create a section. We need beam in that truss. Okay, single line 1D element we are creating. See, cross sectional area is mentioned, material selected. So cross sectional area is 500 square. So everything will be in now. Either you can put everything is meter or else you have to put everything in mm. So cross sectional area 500 Now assign that section. Select assign section tool. Select the region to be assigned the section. So from viewport, select the part, click on depth and assign the section. See, material is assigned and color is changed. Now we have to apply the boundary condition, that is one in fixed and one in 1000 Newton load. Clear? See, we have to fix the one end and then we have to apply 1000 Newton load at other end. So go to assembly first, then create instances, select part and okay, so it is started from origin. Okay, it is started from origin because we created a part from origin. Okay, otherwise you have to shift that part to the origin. That's why always start with origin. Then go to step, create a step. We need stresses, static analysis. So linear distribution because only one instance is required, no time required. That time means what? 10 second के लिए आप load apply करोगे. So we don't need that. We only need an instant. We will calculate the stresses at that particular instant when that 1000 Newton is applied. So static, linear, continue. Okay, so description is what? We are applying load. Okay, then go to load. First of all, we will fix the one end. So create boundary condition encasted. Fixing means encasted. Step 1. Continue. Select this particular node. Done. Click on encasted. That means U1, U2, U3 means what? U1 means displacement in X. U2 means displacement in Y. U3 means displacement in Z. 1 represent X, 2 represent Y, and 3 represent Z axis. R stand for rotation. So rotation along X, rotation along Y, and rotation along Z is equal to 0. All degrees of freedom are restricted for this particular point. Click on OK. See, that point is fixed now. Then next we have to apply the load at other end. Go to load, create load. We need concentrated force of 1000 Newton. So select concentrated force, continue, select that particular point node, click on done, and then see send concentrated force in 1, concentrated force 2 means 1 means what? In X direction, 2 means in Y direction. We want in X direction and positive because it is acting in a same direction. X, if it is acting in opposite direction, we have to mention negative sign. But now it is in same direction, so 1000 Newton. Okay, see the load is applied here. Okay, so loading is completed. That means we apply the boundary conditions basically. Go for meshing. We are creating a single element 1D with two nodes. So go to seed by edges. Before that, select part bar. Go to seed by edges. Select that particular part. Click on done. We need only single element. So we'll go by number. We need, see, if you select 4, it will break into 4 elements. The total nodes are 1, 2, 3, 4, 5, and elements are 1, 2, 3, and 4. So we want only one number of element. So apply. So one element is having 2 nodes. Okay, apply. Okay, and done. So this element is created. You can check from tool, query, mesh. Okay, assembly, mesh. So basically it is only, we don't mesh it, first mesh it, select part, then mesh it. Okay, mesh. Now you can check query mesh for model. So total number of nodes 2, total number of element 1. Clear? Okay, let's go to the assign element type. Select from viewport, click on done. So we need what? We basically have to find out stresses. So select truss element, that is a 1D element. So type T2D2A2 node, that is linear 2D truss. 2D means X and Y dimensions only. Okay, so machine is also completed. Now we can conduct analysis. Go to job, job manager, create a job, just give the name. Okay, bar of constant cross section area, or just give the name of problem, whatever you want. So say problem 1-1. Okay, continue. Okay, check the data. Data check means the model you created, is there any error or not? It will specify. If check is completed successfully, then there is no error while creating a model. If there is error, we can correct it. So check is completed, that means there is no error. Let's submit the job for analysis. So previous part we conducted, that is pre-processing. This is analysis, and then comes result visualization, that is post-processing. Okay, check the monitor, and it is completed. Okay, go for results. Now check. From here you can visualize, see on counter. So it's showing stresses. First of all, we check for displacement. Okay, this is the displacement now. See, blue having value 0, red having value 9.524 e raised to minus 3, means how much mm? That is 0.009 mm, and the maximum displacement is at free end, and the fixed end we are having 0 displacement. If you use analytical method to calculate the displacement, you will get the exact results. Okay, then we can see the stresses. So check the stresses. Uniform area, that's why stresses are also uniform. Okay, then go for forces. So here we get, at free end we applied 1000 Newton, right? So at fixed end we are getting reaction. of 1000 newton. Okay, so this is how you can create a problem and analyze it. Okay, so you have to write down step-by-step procedure from part, which tool I selected, which command I selected. Write it down in document file step by step. Okay, and then take a screenshot of this results, that is visualization, for reaction force, then for displacement, and then stresses, and you have to attach those pics in your results. Also values you will get from counter here. Okay, this is legend. So you will get u2, you will get reaction force at fixed end, that is node 1, and you will get stresses. Okay, and then calculate using analytical method and compare the results for deformation, for stresses, and for reaction forces. So stress, reaction force, and displacement. That's it. Okay, so first video is completed. I'll upload second one shortly.